First thing that we're going to do is solve inequalities. And when we solve inequalities, we really treat them a lot like equations. What you do to one side, you do to the other. We're always going to do the opposite operation. So the opposite of addition is subtraction. The opposite of multiplication is division. But we do have two additional rules. There are two different things that can happen that will make us have to reverse or flip that inequality symbol. The first one is when we multiply or divide both sides of the inequality by the same number, or sorry, by the same negative number. Negative is the key word here. Okay, so if we multiply or divide by a negative, we need to flip that sign, and that's when we're going to end up flipping these the most. But we also will need to flip these inequality symbols if we change the numbers or the number in the variable on the other side of the inequality. So what I mean by that is something like this. If we have 7 is less than 9. Okay, if you remember back in elementary, treat this as a little Pac-Man. The Pac-Man always eats the bigger number, right? If I flip these two, now the Pac-Man needs to still eat the bigger number and needs to flip this. And so now it reads 9 is greater than 7. So if we flip our numbers, we need to flip that inequality, or if we have something like on that previous page here, actually, let me show you. Okay, on the previous page, we wrote these inequality symbols. Why does this work? Well, this one right here is in the right form. X is less than 2, so you have that 2 shading everything less than 2. This one, however, is backwards. If I took this one here and rewrote it, this would be X is greater than -1. Now I'm shading everything that's greater than 1. So when I flip these around, you have to flip that inequality symbol as well. And so when we don't have our inequalities wrote from least to greatest, that's going to happen. Okay, so let's solve here. Example 2, solve the inequality, which is what we're going to do underneath. Then we're going to express our answer in set notation, interval notation, and then graph. So 4 different things for each problem. Okay, so let's start by solving. Treat this as an equation. If I wanted to solve for x, first thing we would do is subtract that 4. And then I'm going to divide both sides by 2. So I'm going to get x is less than 4. So subtracted the 4. 12 minus 4 is 8. Divide by 2. 8 divided by 2 is 4. So in set notation, this is the set of all x such that, and this is what's in my math lab, and you are just putting in that x must be less than 4. So let's go ahead and graph that, and that to me helps with interval notation. If x must be less than 4, we're going to put 4 here in the middle. And if I am shading, I want everything less than 4 or everything to the left of 4. And because that's less than and not less than or equal to, we'll have a parenthesis. So what does this look like in interval notation? Well, it's going from -infinity to 4 with a parenthesis. Okay, trying again here. These are almost identical, except now instead of having a positive 2x, we have a negative 2x. Let's see how that affects this. Still start the same way. We're going to subtract that 4 over. And now I'm going to divide, but I'm going to divide this time by a -2. When I divide by a negative number, we need to reverse or flip that sign. So now this is going to be x is greater than 8 divided by -2 is -4. So x must be greater than -4. So in set notation, we have the set of all x such that x is greater than -4. So what does that look like when we graph? We'll start right here at -4. Use this as an arrow. It's pointing to the right, so we are going to shade to the right. And because it's greater than and not greater than or equal to, we're going to have a soft parenthesis. So in interval notation, least to greatest, we're starting the shading at -4 with a parenthesis, and it's going to go to infinity. Now C is very close to B, except now we have a compound inequality. So now what I do to the middle section, I need to do to the outer sections here. We have 3 different parts. So I'm going to subtract 4 from all 3 portions of this. So I've got -4 is less than or equal to -2, which is less than 8. And now I'm going to divide everything by -2. Negative over negative is positive. Because I'm dividing by a negative, I'm going to flip this inequality symbol. These cancel here, so I'm left with x. 8 divided by -2 is -4. And again, because I'm dividing by a negative, this less than changes to greater than. Now, when we write these in our compound inequality, this always needs to be from least to greatest. And right now, this is greatest to least. So I need to flip this. So -4 is going to come over here. 2 is going to come over here. And I need to flip this. So here, this was greater than. Now it needs to be less than. Or if you want to think Pac-Man style, your X here is getting 8 by your Pac-Man. And now it's getting 8 by your Pac-Man here. This is greater than or equal to. So now this needs to flip over here to less than or equal to. Your Pac-Man was eating your 2. Now it's eating your 2 over here. So we had to flip it to then ultimately flip it on back. Okay, because this always needs to be least to greatest. So in set notation, we're just writing what we found here and here. So -4 is less than x, which is less than or equal to 2. So what does this look like in interval notation? We're going from -4 to 2. If you look at it from this spot right here, x is greater than 4, so this way. And then here we have that x is less than 2. So we're talking about everything here in between. At -4, we need parentheses. And at 2, we need a bracket. So in interval notation, it looks exactly like this. We are going parentheses, -4 to 2 with a bracket. Okay, one more example. And actually, why don't you try pausing the video and seeing if you can solve D on your own. Okay, I hope you had time to pause it. Let's solve this. To get x by itself, first thing you need to do is move this 4. So the opposite of a +4 is a -4. So I'm going to subtract 4 from all 3 spots. That will cancel. We got -6 is less than or equal to -3x, which is less than or equal to -2. Now I'm going to divide all 3 sections by -2. So negative over negative becomes +2. Because I'm dividing by a negative, we will flip this sign. That cancels, so I'm left with x in the middle. Dividing by a negative, so flip that sign again. And 2 over 3 we can't reduce, but negative over negative does become positive. Now, is this from least to greatest? No, so we need to flip this. And when I flip where my X or where my numbers are, we're going to flip these inequality symbols essentially back. So this would be less than or equal to, less than or equal to. Okay, so we have 2/3 and 2. They both are or equals to, and we're talking about everything in the middle. We have brackets, and everything in the middle. The set notation is this right here. And then interval notation, we have bracket 2/3 to 2.